So in this video, we're going to be talking about a thermochemistry problem where we're going to try to calculate the change in entropy for a reaction if we're given the equilibrium constant for the reaction, and we're also given the standard enthalpy for that reaction. So the equation that we would use in this case is the Van 't Hoff equation. Oh, this wasn't... All right, there we go. It would be the Van 't Hoff equation, right? So, right, that equation is the natural log of the equilibrium constant is equal to negative delta H naught over R times 1 over T plus delta S naught over R in this case right here, right? So we know K, that's 6.8 times 10 to the 5th, right? We know delta H, which is negative 92.22 kilojoules, right? We know R, that is in, it's 8.314 joules per Kelvin, right? And we're throwing out the moles in this case, right? We don't need it for anything because we're not doing this per mole, right? We're just simply doing it right here so that things cancel out. And so that way we can calculate then what delta S is. So if we take this and we rearrange this equation, right, what we get is, you know, the natural log of K plus delta H naught over R times 1 over T is equal to delta S naught over R. And so then what we can then do now, right, is just simply multiply both sides by R. So what we get is R times the natural log of K plus delta naught over T is equal to delta S naught, right? So that's the equation. All we have to do now is just simply plug in the values that we have. And so we have 8.314 joules per Kelvin times the natural log of 6.8 times 10 to the 5th plus negative 92,220 joules, right? So I converted that negative 92.22 kilojoules into joules so that things cancel out properly and they're all at the right scale, over 298K, right? Over 298 Kelvin. And so we have that right there. We plug all of that in, we calculate it away, and what we get is negative 197.8 joules per Kelvin, right? And that is one way that we can calculate the delta S naught of a reaction, is if we know those values right there.